Hey everybody, I hope you're having a great Tuesday. So yesterday in class I had mentioned that I posted a statement on Edmodo, and the statement was, in a game of rock, paper, scissors, opponents who are familiar with one another will tie 75% of the time. Well, yesterday in class you might remember I told you that this actually isn't my statement. This is a statement from someone much more intelligent than me. It's actually from Sheldon from The Big Bang Theory. In case you've forgotten, let me refresh your memory.
Tell you what, how about we go rock, paper, scissors? Ew, I don't think so. Anecdotal evidence suggests that in a game of rock, paper, scissors, players familiar with each other will tie 75 to 80% of the time due to the limited number of outcomes.
Players that are familiar with each other will tie 75% of the time. Now, is Sheldon lying or is Sheldon telling the truth? What evidence does he have to support this claim? Today is the day we start our investigation to determine the validity of Sheldon's statement. But first, there's a few things you need to know about probability. So without further ado, let's take a look. So first, the probability universe is divided into two parts. And these two parts are constantly battling one another. So the first part is called theoretical probability. Now, theoretical probability sounds like it would be really confusing, but you've actually been working with theoretical probability since you were in elementary school. Let me tell you a little bit about it. Theoretical probability is what should happen during an event, based totally on math. Still confused? Check this out. Let's say that you are rolling a dice, and you wanted to know when you roll a dice what's the probability that you would roll a 4. Well, the probability of rolling a 4 would be 1 out of 6, because on a dice there is 1 4 out of 6 possible outcomes. So therefore the probability would be 1 out of 6, meaning that every 6 times you roll a dice, you would expect to get a 4 one time. That is what should happen. Also, consider a quarter. If you wanted to know the probability of getting a heads when flipping a quarter, it would be 1/2, because there is 1 head on a quarter out of 2 possible outcomes. Similarly, if you had a spinner with 8 different pieces and 2 different colors, and you wanted to find out the probability of spinning an even number, you would have to look at how many evens there are. There are 4 evens out of 8 total outcomes. 4 over 8, or 1/2. It's important to note here that whenever you're using probabilities, you always want to make sure that your probability is simplified in lowest terms. So whether you're rolling a dice, or flipping a quarter, or spinning a spinner, there's always probabilities that should happen based on your expectations from math, whether it's finding out the probability of rolling a 4 on a dice, flipping a heads on a quarter, or spinning a spinner and getting an even. Go ahead and pause this video right now and with your team work on part 1, theoretical probabilities. I'll see you in a few minutes. And when you're finished with part 1, feel free to go on to part 2, where you'll start your investigation on rock, paper, scissors and theoretical probability. All right, hey, well, welcome back. Hopefully by this point now you've already done part 1, theoretical probability, and part 2, theoretical probability with rock, paper, scissors. And by this point, you've already probably found out that the probability of tying in rock, paper, scissors is 3 out of 9, or 1/3. And that's because 3 of the rock, paper, scissors possibilities are ties out of the 9 total possibilities, which would be 3/9, therefore resulting in 1/3. Well, hey, that is theoretical probability, and those are all things that should happen during an event. But as you probably know, things don't always happen the way that they should. So the other half of the probability world is experimental probability. Experimental probability is what actually does happen during an event based on actually completing the activity. So for instance, let's say that I was rolling a dice and I wanted to know what the probability of rolling a 4 was. Well, if I actually roll a dice like let's say 48 times, I might only get 6 4s. So therefore, my experimental probability would be 1 out of 8. Because when I actually did the experiment and I rolled the dice 48 times, I only got 6 4s. Similarly, let's say I flipped a coin and I wanted to know what the probability of getting a heads was. Well, when I actually did the activity, I flipped the coin 100 times and I got 34 heads. So therefore, my experimental probability was 34 out of 100, or 17 over 50. Finally, let's say that I actually spun that spinner and I wanted to know the probability of getting an even. And when I actually spun the spinner 200 times, I got 100 times. 100 evens, excuse me. So the probability experimentally would be 100 out of 200, which is 1/2. So this gives you a great representation of theoretical probability, what should happen based on math, and experimental probability, which is what actually does happen when you complete the activity. Hey, speaking of actually completing the activity, go ahead and look at your activity sheet for today and find part 3, experimental probability for rock, paper, scissors, and let me explain what you're going to be doing. So hey, here's where we will start to play rock, paper, scissors. And if you remember from yesterday, we're actually going to play rock, paper, scissors 3,450 times. Or in other words, everyone that I teach is going to play rock, paper, scissors for 20 games. Here's how it works. Right now, you're sitting in teams of 3, and every person in your team will play another person in rock, paper, scissors. During a game, you'll pick one player to be player 1, you'll pick another player to be player 2, and then the third player will be the data recorder as the 2 players play. So for instance, let's say that Miss Weber and I are playing rock, paper, scissors, and in game 1, I win. Then in game 2, we tie. Then in game 3, we tie. Then in game 4, Miss Weber wins. Then in game 5, I win. Game 6, well, of course, I would win. Game 7, of course, I would win. Game 8, I would win. Game 9, I would win. And game 10, of course, well, I'll just be nice, we would tie. So that's how you'll record your data for rock, paper, scissors today. Then you'll go on to your next game, and in your group of 3, you'll write the names of 2 people who haven't played yet. And the other person will be the recorder. And then finally in the third game, your remaining 2 people will play. And that third person will be the recorder. So when you're finished, you'll have 3 sets of game data and everyone will have played twice. Hey, if you have any questions about today's lesson, this is where we're ending. But if you have any further questions, feel free to jump on Edmodo. I should be available all day to chat. And have a great time today. And please be respectful of our guest teacher. Thanks so much.